All right, so now we're going to go back to looking at symbolizing our vector data. But now, instead of doing like a single symbol, we're going to work with displaying the data using the actual attribute information. All right, so here I have this county level data for like the upper Midwest part of the country. In the map, I changed the projection to Webb-Mercator projection, which made sense for this extent. So right now it's displayed as a single symbol, but I would like to actually display, in this case, the percent of the county that's covered in forest. Okay, so we want to change this now from single symbol to graduated, and that creates this graduated symbol symbology. And then we need to pick a value to actually symbolize. In this data set, this Wester 158 is the percent forest cover, which I derived from the National Land Cover Database. And then we could pick a collar ramp. So for this data set, since it's forest, we can maybe do like a green ramp. And then we actually need to assign values to collars. So to do that, we have to use some type of classification method. So we have count, equal count, or quantile. That's basically puts an equal number of map features, in this case counties, into each classification bin with equal intervals, so an equal an equal range of values in each bin. Logarithmic scales, which doesn't really make sense here because it's not really distributed that way. Natural breaks, that uses an algorithm to try to find gaps in the data distribution. Pretty breaks tries to create breaks that are on nice clean numbers like tens, fives, hundreds. And then standard deviation is variance relative to the mean. So we'll just stick with quantiles for now. This allows you to change the number of classes. So we'll just stick with 5. I think that seems reasonable. This a couple other options. This precision, that's like how many decimals it's going to show in the legend. So we could cut that down to like 1 decimal value if we wanted. What else do we want to do? I think that's basically it. If you wanted to add like percents to the legend, we could do that. So I'm going to add in a percent sign there. Okay. And let's do an apply. So you can see the legend over here. And I think that'll do it. So let's hit OK. So now we have a Choropleth type map where colors represent ranges of, in this case, percent forest cover by county. All right, so just to change this a bit, just to show you a few other options, you could apply a transparency if you want. I don't feel like that's useful in this case, so we're gonna put that back to the setting or to the default there. You could use a different classification method or a larger number of bins. So, for example, this is too many, but we could apply more bins of data. We could use a different stretch. So, for example, we could use pretty breaks. Let's go back to 5. See nice clean numbers there. It's a weird distribution though. We could do like an equal interval, which is probably going to be strange because a lot of them are low. So anyway, change the classification method. And then also, obviously, you could change the collar ramp. So we'll go to all collar ramps, and then, I don't know, like a yellow to green. All right, so that's some examples of Choropleth mapping. Another thing you might want to do is, instead of trying to show a unique value, a continuous value, you might want to show unique value, like qualitative or categorical data. So I'm going to open up this geology layer for South Dakota, and we'll look at displaying it with unique values. So I'm going to go to properties again, and then it's telling us we got to do some data transforms here, or projection transform. Again, it's just single symbol now, but what we would like to do is categorized. And then you got to pick a field to represent the different categories. So we'll just do this rock type 1. And then we should be able to do classify, and then it adds all your different rock types. And then you've got a couple options. You have random callers. We do shuffle random callers, and then it will just assign different callers to each one. So you can play around with it until you get something you like. This is probably too many categories, really. So if we do an apply and an OK, now we can see that we have a unique caller applied to each of these different rock types, and then they're listed there. If you wanted, again, you could symbolize on something else that's continuous. So for example, we have unit age, which is yes, so we want to delete it and let it, there we go. And then again, we could go in here and shuffle the callers. And there we have a categorization based on rock age as opposed to rock type. And lastly, if you want, you can go in here and you can edit the legend categories. So they display the way you want if you were going to say make a map layout.